Yikes! Get me out of this! Get me out of this! Ah, there we go. Ha! Welcome to another chemistry review video. This one is 1.04, rounding off answers. To what? To math problems using measurements. Here's how it works. After today, you will never have to ask where to round your answers off to again. Lucky you! So, if you're rounding off addition and subtraction problems, your answer cannot be any more precise than the least precise measurement that went into your calculation. So, for example, when we add these three numbers together, our first measurement is precise to the tenths place. Our second measurement is precise to the hundredths place. And our third measurement is precise to the thousandths place. Why? Well, because in any digit and any measurement with a decimal point, the rightmost place is where the precision is. My answer cannot be any more precise than the least precise measurement. And therefore, since this only goes to the tenths place, we have to round our answer off to the nearest tenth, 42.3. But wait, we're not done yet, because now you look in the next place to see if you round this up. If this was 42.34, we just leave this alone. But because it's 42.35, we round this up to 42.4. Make sure you always include the unit, because any number that doesn't have a unit is meaningless. 23,000 plus 8.7 equals 23,008.7. Well, anybody can do that. But as far as precision is concerned, this first number does not have a decimal point, so the precision is wherever the integers end, the thousands place. The second number does have a decimal point, so our precision is the last digit, the rightmost digit, which is the tenths place. The least precise measurement is the thousandths place, which means we need to round this number off to the nearest thousand. And so it's 23,000. We look in the next place. Now, if this is 23,700 and something, that would make this 24,000. But because it's not 5 or above in the next place, we just leave this alone at 23,000. Now, you may be tempted to just round it off to 23. But let's say I owe you $23,008.70, and I say I'm going to round it off to the nearest thousand. Here's 23 bucks. Do you think you'd have a problem with that? I know I would. Addition and subtraction continued. The first measurement doesn't have a decimal place, so the place we rounded off to here is the hundreds place. The second measurement does have a decimal point, which means it's precise to the tenths place. The less precise of these two measurements is the hundredths place, so we round our answer off to the nearest hundred. The 2 in the next place does not round that 6 up at all, so it's 6,600, and we put 2 placeholding zeros here to keep the number the same size. In this next example, there's a decimal point, so our precision is the last digit, the tenths place. In the next measurement, there's also a decimal point. The precision is the last digit, which is the 10,000ths place. The tenths place is less precise. Therefore, we round our answer off to the nearest tenths. And since the number in the next place is 5 or higher, we round it off to 8.1. And that's how to round addition and subtraction. Now, we're going to just skip past that. Multiplication and division. The answer cannot have any more significant figures than the measurement with the fewest sig figs that went into the calculation. Now, it would be so much easier if we could just use the rules for addition and subtraction for everything, because then we'd only have one rule to learn. But because multiplication and division are not done the same way as addition and subtraction, we need a different rule. So here's the rule we use. The first measurement, bigger than 1 with a decimal point, they're all sig figs. The second measurement, bigger than 1 with a decimal point, they're all sig figs. So we're going to round our answer off to the fewest number of sig figs, which would be 3. We count these sig figs in from the leftward side. 1, 2, 3. Now, whatever place that is, that's the place we're going to round it off to. And since the number in the next place is 5 or higher, we'll round 619 to 620. But we can't just write it as 620 to show 3 sig figs. We need to write it as 620 with a decimal point. You see, 620 without the decimal point would only be showing two significant figures. So we need that decimal point to keep our rounding correct. Second example, the first digit is bigger than 1, but there's no decimal point. The line represents the end of the precision, so there's only two sig figs. The next number is bigger than 1 with a decimal point. They're all sig figs. So the measurement with the fewer number of sig figs would be 2 sig figs. So we count in 2 sig figs from the left side. That would be to the nearest 10. We look in the next place, we see that there's a 6 there. That will round this up to 670, and we put a placeholding 0 to keep the number the same size. And by the way, centimeters times centimeters equals centimeters squared. You have to keep track of the units as well when you do your measurements, your math. Next example. 30 has two sig figs, bigger than 1 with a decimal point. 3 has only 1. So we're going to round our answer off to one significant figure. That's to the nearest 10. And 10 to the nearest 10 is 10. No decimal point because we only want to show one sig fig. And grams divided by milliliters is grams per milliliter. Same thing here. Bigger than 1 with a decimal point, they're all sig figs. Bigger than 1 with a decimal point, they're all sig figs. The fewer number of sig figs is 2. So we're going to round our answer off to 1, 2, two significant figures. But this point, we want to show this as a significant figure. So we're going to round 10 to 10, except this time with the decimal point to show the two sig figs. In the last example here, bigger than 1 with a decimal point, 3 sig figs. Bigger than 1 with a decimal point, 4 sig figs. The fewer number of sig figs is 3. So we count in 3 sig figs from the left, and that takes us to the nearest 10th. So when we round this time, we'll round 10 to 10.0 to show 3 significant figures, grams per milliliter. And that is how to round addition and subtraction and multiplication and division. Once again, I hope this has been of great help to you. And until next time, this has been Mark Rosengarten's Chemistry Review. I wonder when that's going to start getting old. My guess is probably now.